this is the webinar that we are planning to conduct today. I have a couple of housekeeping issues that I would like to go over. The webinar can be attended using either your computer speakers or a toll phone, but hopefully not both. I think it'll create some distortion. During the presentation, everyone will be muted, and you should be seeing this screen here on the left. And I would urge you to ask any questions through the dialog box here indicated in yellow. And because we're viewing a lot of data in rows and columns today in Reveal and OpenCDISC, it's most likely best if you enable this particular icon here for full screen viewing so that you can see the data clearly. We will be handling as many questions that you submit in the dialog box as time permits, but rest assured that we will also be sending a summary of the questions to you shortly after the event. This is your control panel. Just to give you an orientation to that, you can open and close the control panel using the orange arrow tab. Obviously, most of you, I believe, would be enabled audio through the mic and speakers, but you could be here via telephone using a dial-in number. I should also tell you that today's presentation is scheduled for about 60 minutes, and it's being recorded, and we will provide a link to you via email within 48 hours after the event. Here's a brief overview of what we'll be covering. I will be going through an overview of the features and benefits of Reveal and OpenCDISC Validator. And then Ian, our Principal Senior Life Sciences Consultant, will be demonstrating Reveal, showing a few search scenarios and how the product can be used with OpenCDISC. And here's what we think you'll learn during the webinar. So basically, Reveal is the only clinically aligned web-based enterprise search platform that can search the content of SAS datasets as well as other file types, making it far superior to existing enterprise search and embedded search products. Reveal also searches across unlimited number of data stores and gives pharmaceutical companies a virtual window into their cross-platform clinical data systems. It supports most major commercially available clinical data repositories and host file systems, and it can find and organize your data, making it extremely useful when combined with third-party software utilities and analytics tools. Today, Ian will be demonstrating one use case where Reveal is combined with OpenCDISC Validator to validate data for CDISC compliance. Reveal can search most file types found in clinical and regulatory environments, allowing you to look at all of your data, metadata, binary data, tables, and once again, even data sources previously impossible to search, like SAS Datasets. And because Reveal has the ability to search the contents of SAS Datasets, it performs robust metadata search capabilities, so end users can perform clinically relevant searches. Everyone knows that metadata describes information about the data like content, format, intended use, origin, derivation, etc. And with metadata, we're able to facilitate information flow, improve retrievals, help discovery, and provide context to the data. As an example, Reveal can pick up all assigned attributes in a SAS dataset or another file type held in a CDR, like the word or attribute phase, for instance. By performing a metadata search for the metadata term phase, you can effectively organize or isolate your search parameters. Other enterprise search products have much more modest metadata search capabilities because they don't index all of the content in a dataset or file. Many of our clients tell us they are awash with competing clinical applications, but Reveal gives them a window into their cross-platform clinical data systems. It is designed to perform a federated search across all of these various data sources, and search them simultaneously, building a single search index that can include multiple heterogeneous data sources. Even if your data resides in different physical locations, Reveal consolidates the information into one searchable body of knowledge. So, to recap, Reveal can search all of your data rapidly, saving precious time. In seconds, you can access every data repository across your clinical environment and find the necessary data and export results to analytical tools or other tools like OpenCDISC. Reveal also recognizes data sets that are organized in rows and columns and that most other search products miss. It extracts the data, sets metadata, along with the rows of data. Both are indexed and available for searching. Reveal also searches structured and unstructured data, as well as specific terms, and identifies files containing specific clinical information. By reducing the time it takes to find clinical information in unwieldy data repositories from days to seconds or minutes, Reveal saves significant time and money and provides a real competitive advantage to answer those time-critical questions. Some of our current Reveal clients are using Reveal for these types of different use cases. Today, we'll be showing a use case with OpenCDISC. For those of you not familiar with OpenCDISC, it is a free software used for ensuring clinical data compliance with CDISC standards like SDTM, ADaM, and defined.xml, and others. Ian will show you later how that works. OpenCDISC Validator is a metadata-driven and configurable application with checks defined using an XML-based validation framework. It has the power to support a wide range of rules and data formats, even custom data sets. So before we see how these products work together, let me just give you an idea of what you'll be seeing. Ian will cover more as he does the demonstration, but generally, he'll be showing you how Reveal feeds other tools like OpenCDISC and JMP and Spotfire, how Reveal can find data you didn't even know existed, and how it helps you organize your data, which can be extremely helpful when introducing new programmers to study data. And of course, how it works closely with OpenCDISC. So what I'm going to do is I'm going to transfer my control to Ian at this point, and hopefully Ian will be able to show you his screen. Are you there, Ian? Ian? Oh, sorry. Are you there?
Hi, Keith. Sorry, you had me muted there.
Yeah, sorry.
Okay, that's okay. So I'm Ian Fleming. I'm a principal life sciences consultant at DWise, and today what I'm going to be doing is actually going through a quick demo of Reveal, and then also how we integrate that with, well, not integrate, but how we actually use that in conjunction with OpenCDISC, or how it could possibly be used in a use case to actually check the validation of data sets for submission to the FDA or against CDISC standards. So on my screen, what you can see is the Reveal product. It is a web-based tool, so you can just get through it through any web browser. The version we're running here is a demo version, so I'll just log into that. And you'll see the user interface here is actually pretty simple. It's similar to a Google search box, where you just have a simple search box where you want to search for something. So let's say, for example, we just want to do a quick search for CDISC, just to see what that returns. So if I type in CDISC, I actually get a whole bunch of information here that is returned. And I'll go through this in a little bit more detail. But on the source side, you can actually see what source means in this case is it means all the indexes, all the things that we're actually indexing. So in this case, what we have is we actually have three different sources. We have a cardiovascular source, we have a CDISC source, and then we also have a CAMD source that actually didn't come back in this particular search, but we do have it indexed in the background. So when you look at all the individual items that are returned here, what you're seeing is a bunch of different pieces of information. So this first set here is Excel spreadsheets from the cardiovascular index, and what you can do is you can actually launch these Excel spreadsheets right from here. And the reason why I was returned from here is actually that there was CDISC was something that was within the file, so it was actually returned by the tool. And so when we launched that, we can actually see this is a metadata spreadsheet, so it's like what you typically see as an Excel spreadsheet that is describing some kind of data. And if you go over here and you go to the spec tab, what you can see is you can see here, let me blow this up a little bit so people can see it. What you can see is that in this spec tab, there is the word CDISC in one of the cells. So you can see that Reveal is actually indexing every single tab that's within this Excel spreadsheet. And when you search for CDISC, it's actually returning this file because this particular string of text occurs within this tab. So it's fairly powerful in the fact that it's not just indexing single tab Excel spreadsheets, but multiple tab Excel spreadsheets. You can also see it's returning some PDF documents, some XML documents, some SAS programs here, and there is also some Word documents that it can also return, but we don't actually have any Word documents in this index with the word CDISC in them, but it will actually index all the content within Word documents as well and return results based on searches for that, in addition to what is listed here. So what we can do now is let's just do a quick search within the cardiovascular index. So you can see I clicked on the Help Me button over here, which actually expands some search options here, so you can actually do something similar to like what you would do in Google, where you search for certain words and then without other words and so on and so forth. And so let's just look within cardiovascular. So you can see the 3 different sources that we're indexing here. Let's look in cardiovascular and just see what that returns. And we're going to get everything here. We're not just going to get one thing. We're actually looking within this index. So it's going to give us 378 things, which is all the contents of this particular index. And this is a fairly modestly sized index, but this could return thousands or hundreds of thousands of items if you have a fairly large file server or database or something that you're actually indexing. One thing that I wanted to show here was if you click on this magnifying glass next to this, you can actually, there's this section down here that says Show Unique Metadata Values For. And when you click on this, you actually can see a number of different metadata items. For this demonstration, what I'll do is I'll actually go down and I'll click on Study. And this is a particular metadata item that we implemented in this version of Reveal. And so when you click OK, what's going to happen is down at the bottom of the screen, you're going to actually see all the different metadata, the values of that piece of metadata. And so you can see we have 13 different study values, which tells me within this cardiovascular index, we have 13 studies worth of information. And this metadata set is extensible. Right now, it supports a number of different items that are in here, and you can see a lot of them that are listed here. But this is customizable based on your particular implementation. So if you were to purchase Reveal and you wanted to do the implementation, you could attach any piece of metadata to the indexed items that you would like. And that every single one of these things is searchable. So for example, I could go up to I could go up here into this, and you can see that the way this the syntax works a little bit is that we have source, but if I were just to study, and then I put a colon, and then I say NICSAH1, you can see what it'll do is actually return all of the items with that study, that piece of study metadata. So this metadata is pretty powerful because you can attach any piece of metadata to these elements and objects that you would like, and then you could easily search on that within Reveal to get all the items that actually meet that criteria for that piece of metadata. Okay, so let me go ahead and turn that off. And that screen will always be on the bottom there unless you go ahead and turn it off. So I'm going to just turn it off, so we're not going to get that anymore. But the contents are still there. We're just not showing that extra piece of metadata. So now let's say, for example, I want to do a search for Alzheimer's information. I know that I have some index that contains a lot of Alzheimer's information, but maybe I have multiple indices and I actually want to see which of them contains information about Alzheimer's. So what I can do is I can just start typing Alzheimer's. You can see the autofill actually happens there. This is a user-based autofill. So if you've searched for something in the past, it will automatically fill in based on your relevant search history, similar to Google. And so I can just select this, Alzheimer's, and I can do a search. And what comes back is I see that CAMD, things that are in the CAMD index actually have a lot of information about Alzheimer's. And let me explain a little bit like what you're seeing on the screen here. So you have the source, the index where it's coming from, the folder, where it's contained, the actual name of the item. And so you can see what we have here is we have a lot of SAS datasets. Reveal indexes SAS datasets out of the box. There's no additional work that needs to happen. And so you can see we're getting all these returned. You can see the type of file that it is, the size of it, when it was mass modified, the path that you can click on to actually open it inside of Windows Explorer or something like that. And then it actually gives you some little information in the notes column that tells you how often that search term appeared in that particular item. So, for example, in this CM dataset, this concomitant medication dataset for study 1014, there's 207 matches for Alzheimer's. So within that dataset, we actually had that search term occur 207 times. But let's say that what we wanted to do is, instead of looking at individual data sets, let's say that we wanted to see how many studies do we have in CAMD. So what we can do is we can go back to this Help Me tab. So what we'll do is, we'll change this to CAMD. What I can do is I can change the type here to folder. And so we can see from that previous screen that we seem to have a folder-based hierarchy where studies actually are folders. So we can just go ahead and run that search. What you're going to see here is you're going to see about 16 items returned. You can see the CAMD, which is the high-level folder, which all the others are contained in. We have a subfolder within this 1,000, and then we actually have all these studies here. So you can see we have about 14 studies worth of data in here. And all we did was just narrow the search type to this particular index and then this type of folder. But that's kind of some structural searches that you can do. But in addition to that, what you can do is you can start looking within your data to find out, to help you answer questions that you necessarily didn't know that you have, or if you have a safety signal that pops up and you want to start taking a closer look at it, you can start doing that. And so you can see the syntax here. You can use the point-and-click interface to actually do some searches. So you can use the Help Me button or this spyglass or the magnifying glass over here. But I'm just going to use the syntax to do some searches. So what I'll do is I will just say, source is CAMD. We do support wildcards, so you can just put a wildcard in there. And then let's say that we have a particular safety concern for African American patients. Within this Alzheimer's drug or within this the CAMD project, then what we can do is we can just do a simple search here, right? So I just say the source is CAMD, which will limit it to that particular index, and then I'm just going to search for African American within that index, and you'll see what returns is some demographics data sets. It returns some dispositions, a supplemental qualifier for disposition, and then some other items down here, mostly demographics, which is what you'd expect to see if you are actually looking for a race category such as that. And based on this, what you can do is you could actually open these items. So if I were to just click on this, it brings me to kind of my somewhat familiar Windows-based file application extension opening dialog. And then what you can do is you can just open in SAS Viewer, and then you can see here that you have, here's your race column. If you actually go down, we can find, here's African American. You can see that search term actually occurred right here, and it actually occurred up above as well. So you can see that, based on that search, it's actually returning these files where the contents actually, contain that search term that we're looking for. Okay, so based on that, you can open, open things. You can do a little more refined searches and maybe some more hardcore analytics based on certain particular aspects of interest. Another thing that Reveal can do is it can actually return some very basic information about files. And if you structure the syntax correctly, you can actually get some information. So for example, let's say within CAMD, I actually want to look for files that actually have variables with a certain value. So say, for example, I want to look for sex equals male. What I can do is I can actually just run this search within CAMD. What I get is I get all this DM data, which is what you'd expect because DM has a variable called sex, and when we put a colon here, male is the value of that particular variable. And so what we're doing is we're getting all these DM data sets returned, but if you look over here at notes, what you can see is you can actually see the number of records within that particular data set that met that criteria. And so you can see here, for example, we have 58 records here that have the criteria of sex equals male being true. And so, you know, the DM data set, we know that the DM data set, according to CDISC, is a 1 record per patient data set. So that inherently would mean that we have 58 males in this section and then 160 males in this one as an example. But you can also do compound search. So if I were to say sex equals male, and then I were put, or sex equals female, right? That's going to give me a bunch of different results, but you can see the basic, what it returns right here is it returns information about each one of those compound search, or each element of that compound search. So you can see 58 matches for sex as male and 82 matches for sex as female. And so you can start doing, some very basic looking into the data sets. It's not meant to replace, some of the more powerful analytics tools that are out there, but the intent of this is just to give you a quick snapshot of what you're looking for and actually help you find, information that would help you guide your analysis in whichever way you're actually going to be doing it. So within Alzheimer's, there is one particular concomitant medication that is used very often in conjunction with it, and it's called memantine. And so what we can do is I can do a quick search for memantine, and what I'll see is I'll see a lot of these things that come up. There is a disposition data set. There's some concomitant medications data sets. These concomitant medication data sets aren't really all that surprising, but the disposition data sets, that's a little bit weird. And so what that would probably mean is that we have some particular disposition. So there's a patient who probably discontinued, and part of the reason as to why they discontinued may have something to do with this medication. And so once I get in here, I can actually just go in and I can, it's possible I could browse through here and actually look for that memantine reason. This is SAS Viewer, but it's also possible that you can open this in other formats as well. So if I click on this icon here, I could actually open this in HTML, and what that would do is it would actually open it, right in the browser. And it's not exactly the sexiest formatting you'll ever see, but it's pretty nice if you want to just look at something really quick and then do a quick search for memantine. So you can see here that this patient, 1046, had a disposition event where he withdrew. And the reason why he withdrew was that they no longer wanted to participate, and they wanted to take this memantine instead. So I mean, it's a pretty powerful tool to actually help you find some particular pieces of interest, which typically in the past would require a lot of time and digging into the data that you wouldn't necessarily. It wouldn't necessarily be productive to spend a lot of time to find little details like that, whereas this makes it. So this. It also supports fuzzy search. So if you put like a little tilde after memantine, what it'll do is the fuzzy search will basically say, okay, I'm going to look for things that are similar to memantine, not necessarily looking for the word exactly. It's actually going to do a search for words that may be misspelled. So if there was an investigator that put something into into the form wrong, or they misspelled memantine or something like that, what you're going to see is you're going to see a lot of different things here. So we kept it really fuzzy, and so what you're going to see is a mesangial here, recasting remaining clemenstein. There's a lot of things here that actually were returned because it's just doing a fuzzy search, but you can see it's returning a lot of different things based on extremely loose parameters. So what we can do is we can just put a little number after this, and I think this number basically just narrows down the search and lets you, it gives the fuzzy logic some indication of how fuzzy it should be. So you can see here that when you set this to 0.08, now you actually have a couple of different things here. It still finds all the things that are memantine, but you can see in this one right here, it's finding memantine, but it's finding memetin and memantine, right? And so you can see there's some differences in spelling here, but you're just narrowing it down much more closely based on this search parameter. Okay, and so let's say as an example, you have some safety concerns. We did the search before. We were looking for sex equals male and sex equals female, but let's just say we're looking at something else. Now we want to say that how many serious adverse events do we have in each one of these studies? So we know the name of the serious adverse events variable is AESER, and then we can just say is equal to yes. And then what it'll return is it'll actually return all the data sets where it has any variable which is named AESER, which also has a value of y. And so you can see in this study 1055, we actually have 37 records where AE serious equals y, which gives us an indication that there was 37 events within that study that were considered to be serious by the investigator. We can do the same thing with related. So AEREL, that's the same thing, and we just do that equals to yes, and you can see here we have 30 in 1054, 30 matches where the records were equal to, where AE related is equal to yes, which indicates that it's a related adverse event. So let's say that we want to just look for death. Let's say within this we want to actually get an indication of the types of deaths, or the types of the occurrence of death and how often that was occurring within this particular submission or within this index. So if we do that, we can see it returns a whole bunch of information. There's some AE variables or AE data sets here, which isn't surprising. There's some disposition data sets, which isn't surprising. We have some medical history data sets, which is a little bit of interesting. So you can actually, because medical history typically doesn't have anything regarding death in it. So what we can do is we can actually, here, let me open that as an HTML file. You can open it as Excel and everything as well. I'll go through that in a second. But if we just were to open it quickly as an HTML file, what we can do is we can actually do a quick look for death. Sorry, it's taking 1 second. Oh, that's a bigger data set. Maybe I should have selected a smaller one. Here, this MH1 is a little bit easier. Okay. So now you can see here we have all this information. If we just do a quick search for death within this file, you can see here, for example, this patient has mild depression after the death of her husband, and so that's patient 1000. And you can just keep searching if you'd like to, I guess that's the only occurrence in this one. So, it's information that you wouldn't normally have access to, and you wouldn't know. I think typically we would think is that you wouldn't see MH having any contents with the word death in it, but it's interesting to actually be able to pull that out and see that insight within this. But in addition to the normal, the normal analysis that you would do around death, which is typically pre-planned, it doesn't allow for a lot of time for discovery and looking for that. So in a lot of these, death is something you may want to explore a little bit further in some of these disposition or AE data sets. And so what you can do is if you right-click or if you click on this, what you'll see is a couple of different options that come up here. You can export this thing as a CSV file, as an Excel file, HTML, which I've showed, and then Spotfire text. So for Spotfire text is a particular data format that Spotfire uses in order to be able to import it into Spotfire and actually do something with it. And we support that now, but it is possible to actually have, integrate this with JUMP or JReview or Comprehend Clinical or anything like that, so that if any of those particular if any of those tools have a particular or file type that they're looking for, it's very easy to actually create that integration, and then you can export it and open it in that file or in that application and do some more in-depth analysis. And these are, the spot-fire text that's supported here is a desktop application, but it is possible for something like Comprehend Clinical or another Java-based application that it is possible that you can integrate with that as well and just launch it within the same browser. Okay, let's go through one more use case, and so this will be the last one before I move to the OpenCDISC portion. And so essentially what we want to do is now, let's say we come across a use case where we want to look for all the SAS programs that we have. So we can do a quick search where we're going to say name is .sas, right? We'll wildcard it, so we can just say *.sas. And so if I just run that, I can see that these are all of the SAS files that I'm actually going to come across. And you can see here there's a whole bunch of them. There's a bunch of them in cardiovascular. And there's some in CDISC pilots as well. And so what we can do is within that you can say, okay, I want to know which of these SAS programs are operating on the variable race, which ones actually refer to the word race and are doing something with it. So you can just add race right after it. And then what you get is you actually get a couple of different results here. So you have one which is a democat.rtf.sas. And if you go ahead and just click on that, you can open it in SAS Viewer. And then what you'll see here is you actually do have race popping up. Let's see. So there's race. It's popping up here. And so you're actually, it's setting some kind of a macro parameter called vars to race and sex. And so it's kind of nice if you were actually looking for variables or for data sets, for SAS programs that are operating on some particular variable. That is something that is pretty powerful to do. And I know that, for example, when I'm writing a lot of macro code, I do a lot of %put statements to output things into the log so that I know the value of certain variables or macro variables and things like that. But in the final production version, you don't want to necessarily be outputting all kinds of stuff into the log. So Reveal is actually pretty powerful for me to use when I'm writing macro code because I can just do a quick %put statement and just point it at the folder that contains all my macro code, and it will tell me which one of my programs actually contain %put statements, and I can go in and remove them before I push the final set of macros to production. So now let's switch over to the OpenCDISC portion where we're going to actually use Reveal to look for some items that we can push to OpenCDISC and check the validation of. I'm not going to go into too much depth about OpenCDISC, but I think we do have some people from OpenCDISC on the phone from Pinnacle 21, and I will I'll let them kind of handle their business, and I won't actually start talking about the product too much. But it's a great tool. There's two versions of it. There's a free version which is available for download from their website, opencdisc.org, and then there is also an enterprise version which has some expanded functionality and some other items as well. So this is just a free version. We do have a customer, or we do have a client that's actually using Reveal right now that does have the enterprise version available, and they are using the two in conjunction. So it definitely is something that could be put into use, in production. And so let's say, for example, I have OpenCDISC open here, and what I want to do is I want to just do a quick search for DMXPT, right? So OpenCDISC operates on XPT files. So let's say that we in-license a drug from some other company, and we actually have done a number of studies, but then we have a number of studies that they also sent to us in XPT format. And what the use case there is that we are going to submit all this to the FDA, but what we need to do is we need to check the validation of the data that we got from that in-license customer. And so what I can do is I can just say, okay, give me a quick search for DMXPT. Okay, and what this will do is it will actually show me all of the items where DMXPT is present. And I can even narrow this down a little bit. So I'm going to say DMXPT, and I'm going to narrow it down to folder. So it's only going to return me, oh, sorry, I forgot to turn that off. So let's just do that. Okay, so what it's going to give me here is 3 different folders that contain an item called DMXPT. And so I can see here that this CDISC pilot 02 M5 datasets study 2 tabulations actually contains a DMXPT file. So what I can do is I can go ahead and browse to that in here. So here's the CDISC pilots, CDISC pilot 2 M5 datasets study 2 tabulations, and I can see all the individual things in here. And you can see DMXPT is one of those items. So what I can do is I can just select all of those things. I'll actually say open, and I can just click start in OpenCDISC. And it takes a couple of seconds here to actually get this done. It's not a ton of data. And so you can see it gives you some quick statistics on what actually happened and the work that it did. And now let's view the report. So the report that I requested was an Excel report. We have OpenCDISC, or sorry, OpenOffice running on this machine. And so you can see here, here's a quick rundown of all the issues that it came across. OpenCDISC actually categorizes things into errors, warnings, and notices by severity. You can see by the color coding here the different types of severity. So we've got a lot of information, or a lot of errors in here that we need to address. So we see it returned about 5,000 errors. And so you can actually go into the issue summary, and you can start looking at some of these. And you can see there's a bunch of warnings. It categorizes each one of them into warnings, notices, and errors. And you can run across your first error here as invalid ARM CD, right? And so you can just scroll down. You can actually see all the errors and warnings and notices and things like that. But this is a lot of information. So maybe what you want to do is actually narrow it down a little bit. So let's close that, and let's go back here. Let's clear this out, and let's actually do a search kind of, we're going to look data set by data set, so we can actually narrow down all the issues that actually occur. So I'm going to include DM here because there going to be some errors that are going to return if you don't include DM, because it's always expecting that data set. So what I can do is I can just view the report. You can see now for AE, there's no errors that actually occur due to AE. There is some warnings that occur, so we can take a look at some of the issues in here. And you can see some of the warnings that are showing up are because we aren't including some other data sets in our search. But then you can start looking down a little bit into some of these other ones. And this, when the source is global, that's something that you should be concerned about. These ones actually aren't of concern because we're just not including those data sets in our analysis. But in AE, you can start looking and saying, okay, in AE, I can see that I actually have a data set variable label mismatch, and that's a problem. And that there's some length issues and a number of different other issues that are actually coming to light here. And you can start sifting through each one of those individual data sets to start correcting those problems. And you can look at some of the details on this tab over here. And then at the end, it will always produce this last tab that has all the rules that are used to actually define what is a warning and what is an error and what is a notice. And you can sift through this if you want. But the real meat of what you should be concerned about is on this issue summary tab, and it should be the basis for starting to validate some of your data. So that's an SDTM example. Let's say that I wanted to do a similar thing for ADSL, right? So if I wanted to do an ADaM analysis, I can do a quick search where I just change DMXPT to ADSL, because ADSL will always be available. It's kind of the primary component of ADaM, and it always needs to be present in order for a submission to be correct. So let's say that I were to change this to ADaM now instead of SDTM. I'll clear this. And then what I want to do is I want to search in the same thing here, in this analysis folder. And you can see all the information here. And if I were to open it, still the same thing. You can actually change the configuration that you want to go against. ADaM only has one configuration, but on the SDTM side, there's a number of different ones you can go against. You can go against 3.1.1, 3.1.2, and so on and so forth. So let's just run this quick check. You can see this kind of high-level statistics here, and you can view the report and see the issues that pop up. And so you can see here that in our ADaM data, we have about 168 errors that pop up. It's not as severe as the SDTM, so maybe we have a little bit less work to do here to fix some of these. And so if you start taking a quick look, you can actually see that within each one of these characterized, you can see some of the errors that you're actually coming across. And then you can go ahead and I mean, this one isn't as severe as the other one. Now, the other one had 5,000 issues or something, which is why I started looking at each data set individually. But this one is fairly nice, and it looks like a lot of the errors are fairly consistent. And it may actually just be a single variable within each one of these that is actually the same variable that has this problem with the label mismatch. So you can just start addressing that in that manner. And then the last thing I think I wanted to show you was just a quick define.xml. So let's say, for example, instead of searching for ADSL XPT, I were just to say define.xml, right? And that should return to me a set of folders that contain something called define.xml. Now, this isn't surprising that the folders that we're seeing here are the same ones that we had before, because whenever you submit something to the FDA, you actually have to include a define.xml. OpenCDISC, the enterprise version, actually has this generate defined XML option, but let's just assume that we've already generated it, or we got it from whoever we were outsourcing, or sorry, in licensing the drug from, or something like that. And then let's go ahead and start looking for it. So same folder, we can go to tabulations. We'll do define.xml, and then you just do quick search. You view the report. The report is fairly similar. What you can see here is you're actually just coming up with one error. So it's a missing or invalid namespace attribute. So that's actually a pretty quick one to fix. It is possible that you might be able to get some more interesting ones. Let's see if we can find one that has a couple more errors, and then we can show some more interesting items. Oh, still just one message. Let's see. So we'll look in study 1. Okay. So this one still has the same issue and missing namespace attribute, but what OpenCDISC will do is it'll actually give you a bunch of information about the structure of the XML file. Structured XML file. Then what it will do is it will actually give you information telling you about what the structural malformities of it are. I think I have one over here that I can show that has some structural malformities, so you can actually see. Okay. Well, I can't seem to find one, but anyways, what it will do is it will actually show you all the structural malformities. So XML requires a certain structure based on the ODM standard, and OpenCDISC will actually check against that standard. And then what it will do is if it doesn't find any issues, it will return a report like this that actually has no issues. But if there are issues, what it'll do is it'll actually tell you what the structural malformities are. So it'll give you the element names. It'll tell you that it is not in the correct location in the hierarchy and things like that. And it'll actually tell you which element has the problem. So then you can start going through that define.xml file and start diagnosing exactly what the issue is. Okay, that's it for the demo. I'm going to hand it back over to Keith and let him pick it up.
Okay, Ian, thank you. Let me just bring up one slide here that I want to show everyone. I did get some questions here during the presentation, which we'll try and address. We're running a little late here. We have only about 15 minutes or so, but basically I should tell you that Reveal can be delivered as a SaaS or on-premise application. And basically, in summary, what we saw here today was that Reveal can search both structured and unstructured data and metadata. It's the only clinically aligned search product that searches SAS datasets as well as other file types. It searches across multiple studies and data stores, including most commercially available CDRs and host systems, and in seconds, not hours or days, making your data readily available and a real strategic asset. It also introduces a self-service model for information and report retrieval and helps organizations respond to the ever-increasing volume and complexity of their data, and enables business leads to find information without bombarding IT and programming with data and reporting requests. So I'd like to go to the question and answers now, and basically what I'm going to do is enable some of my colleagues here to comment. Chris Olinger is our Chief Technology Officer. Chris, can you hear me?
Yeah, I'm here.
Okay. Chris, I think this first question might be appropriate for you. Basically, the first question here is, does Reveal honor the underlying security access of the database it's searching?
Thanks, Keith. My name is Chris Ollinger. I'm the Chief Technology Officer. The answer to this question is pretty simple. We do honor the underlying security mechanisms of any of the objects that we searched. It is fully configurable. The indexes are built without any sort of security in place, and then when the user goes to display results, that security model is checked. The system can be configured in a variety of ways to either display a result but not allow download, or to hide the result from the end user if it is not appropriate. So the answer is yes, and is dependent essentially on the underlying system that we happen to be indexing.
Okay. Thanks, Chris. I have another one here that's sort of in that same realm. Is there any limit to the amount of data that Reveal can search?
Reveal is actually pretty flexible in this regard. We have indexed multi-terabyte sources before quite easily. The system is also designed to work in a federated fashion, so that it can be distributed amongst various Reveal nodes. So from that standpoint, we can handle fairly large indexes and handle fairly large data stores.
Okay. Okay, one last one for you, Chris. I think it's basically, what is the most important feature of Reveal that you feel is useful in a clinical environment?
Oh, well, there's actually a few things that Reveal does do that enables what I would call sort of more clinically relevant searching. I would say that the main things that differentiate us probably are that we are tailored for the clinical environment. So we understand things like studies, compounds, other sort of clinically relevant type of items. We have a very simple metadata structure. If you go back to when Ian was demoing, you noticed all of these metadata terms that you could search on. These metadata terms can be searched or added into the system through a variety of mechanisms, either through user-defined or from inspection of the artifacts that we happen to be indexing. So you can pull information out of things like tabs, out of SAS programming files, out of Word docs from the properties section. I would also say that one of the things that sort of sets us apart is that we do full indexing of data. That is, some of the enterprise search tools that are out there today have some hard limit cutoff on the amount of information that they'll actually index. Reveal takes a great pains to essentially index the entire content and make it available to the end users. I would also say the appearance of the security models is something that sets us apart. And since we essentially index what I would consider as non-standard type repositories that are relevant to the clinical industry, that the underlying security model for each of those repositories that we might be searching are surfaced through the tool. So if you have file ACLs on a file system, we honor those. If you have security structures set up for whatever repository we're searching, we can answer those as well. I would say those are probably the main things that sort of set us apart. That and it's the first time that a clinician or a programmer could get information and answers back within seconds. We've had people tell us in the past that it took them 2 or 3 weeks to find some bit of information across a legacy clinical repository, where if they had Reveal, they would have been able to get the answer within 20 seconds or so. In my opinion, those are the things that sort of set us apart.
Okay. Thanks, Chris. Appreciate it. Thank you also, Ian. Unfortunately, it looks like we're running out of time here, so I think I'm going to have to answer some of these questions in a document that we'll send to you. Basically, I urge you to complete that survey. You'll receive it at the end of the session when I shut down the webinar, or you'll actually get it in a follow-up email that will thank you for attending the webinar, etc. But you might want to also visit our website and go to the resources tab there, where you can download some of the technical documents that we have on Reveal. One is 10 tips on planning your business case for Reveal. One is obviously the marketing data sheet that's available, and then there is a technical document as well that gives you a little bit more insight into how Reveal works, etc. If you'd like to talk to one of our subject matter experts, we have this utility on our website. It's at the upper right-hand corner of the home page. It's called Click to Schedule, and you'll be able to schedule a time that's at your convenience to talk to a subject matter expert, etc. And of course, you can always go to our contact page on our website as well. There's a form there for asking questions or clarifying anything that we may not have covered. And once again, I thank everyone for attending and your time. We look forward to speaking with you soon. Thank you very much. Appreciate it.